Welcome. This is the calculations video where we are going to review the calculations handout, and I will walk you through those examples. So let's start at the top. You will see at the top the text box with the equations called Mifflin-St. These equations will measure someone's calorie needs at complete rest. As you see, there's two. One for men, one for women. Now, to complete the equations, you would need to know the first four things on that list: the age, gender, height, and body weight. We will calculate using physical activity later. So for now, we just need those things. You do not have to remember the equations by heart, but what you should feel comfortable doing is converting pounds to kilograms and inches to centimeters. Why? Because Americans will tell you how tall they are in feet and inches and in pounds, and these formulas use the metric system. So we need to be comfortable calculating those things freely. So let's jump right in and go to the bottom, and we are given this information. We have a female, she's 34, she's 5'5", and she weighs 143 pounds. We'll deal with your activity level in a little bit, so don't worry about that for right now. So let's first convert her measurements to metric. So we'll start with height. So she is 5'5", and as the example shows, we are going to step one, convert feet into total inches. So 5 foot times 12 inches per foot plus all the extra inches below a foot is 60 plus 5. She's 65 inches tall, this woman. So we want to convert those inches into centimeters. So we have 65 inches times 2.54 centimeters per inch. And we do that math, and we find that she is 165.1 centimeters. Now, in height, we don't really care about 0.1 centimeter, which is a millimeter, especially when we're doing calorie needs. So we're just going to round her or whoever's height into the nearest whole centimeter. So in this case, we will round down to 165 centimeters. So that's the first step. Next, let's do her weight. So her weight in pounds is 143 pounds. From the handout and our memory, we know that we divide by 2.2 pounds for each kilogram. And doing the math, we are going to get 65.0 kilograms. Now, I say that 0.0 because if you get 65.45 or 46, you will want to keep and round to one decimal, to the tenths. So, for example, if she was 65.7 kilograms or 76 kilograms, you could round to 65.8. Why? Because that 0.8 kilograms is important enough to include. So, lucky for us, she's just 65 even, so that's what we're going to use. So now let's plug those numbers into the equation. So we're going to pick the female equation and solve for her resting energy expenditure. So that equation is 10 times her weight, which is 65 even. And then we're going to add 6.25 times her height in centimeters, which we know is 165. Then we are going to subtract 5 times her age in years. And then we are going to just subtract 161. You notice that the formulas are identical, except for the women's equation, you subtract 161, and for the male equation, you just add 5. So back to the equation. Let us remember that we do everything in the parentheses first, and then we do the other operations. So doing the multiplication inside, we're going to get 650, and then that's going to be added to 1,031. We are going to subtract 5 times 34, which is 170, and then we are going to subtract 161. So doing that math, I'm going to get 1,690 calories. So that is this person's resting energy expenditure. Moving to the next page, you'll notice that we did steps 1 through 4 just a second ago. And now we are going to do step 5, which is to include her calories from physical activity. So these are the factors that you would not need to memorize, but would need to be able to plug into this equation, which is quite simple. So what this is doing is we're going to pick which category she's in, and then we're going to multiply it times that activity factor. Now, the client, the patient, whoever you want to call them, she does 4 times a week running for 60 minutes, and that's 5 miles. So that's about a 12-minute mile. So let's see how active we think she is based on these descriptions. So she's not sedentary because she exercises, so we can skip that one. The lightly active is defined as 1 to 3 days a week, but she exercises more than that. So let's look at the moderately active. That is listed as 3 to 5 days a week. So that is what she does. And it's moderate, it's 12-minute mile. That's not that fast. So I would say that that's probably it. But let's look at very active just in case it's close. That says hard exercise 6 to 7 days a week. So I don't think she's quite at that level. So thus, we're going to use moderately active. So that activity factor over here is 1.55. So it says multiply times 1.55. So the equation that we're going to do here is on the right, REE times the activity factor. So we know that her REE is 1,690, and we are going to multiply that times 1.55. Now, essentially what you're doing is you're adding 55% more calories to whatever she needs at rest. When I do that, I get 2,619.5 calories. Now, a half a calorie is also negligible. So we're always going to round to the nearest calories in anything we do with nutrition. So I'm going to round up, since that's 0.5, and give her 2,620 calories per day for all her activities. That should be sufficient for her to maintain her body mass or body weight. If we need to change body weight, then we would have to manipulate those numbers, but we're not going to deal with that today. The last section in this lesson is calculating grams from the percent of calories from a macronutrient. Why do we do this? It's because that's the way we describe nutrition recommendations to people. So the first step is going to be to determine the total calorie needs, which we already did. And then we have to decide how much percentage of each macronutrient the person would need. Now that you're going to learn during this class. We're just going to give them to you today so that you can learn how to do the math. If you multiply the person's total calorie needs or total calorie intake times the percentage of the macronutrient, you will find the macronutrient, the calories from the macronutrient. Well, that's not grams, is it? And if I told someone to eat 400 calories of protein, they would probably be confused. But if I told them to eat 100 grams of protein, they would probably understand that a little better. So then we need to do step 2, and that would be to calculate the grams from the calories from the macronutrient. And that's easily done by dividing the calories by the number of calories per gram. Now, this next section where it says how many calories per gram for each macronutrient is to be committed to memory. Okay, so you should know that 4 calories per gram of carbohydrate, 4 calories per gram of protein, 9 calories per gram of fat, and 7 calories per gram of alcohol. Alcohol is not a macronutrient, but it does have calories. For today's example, we're not going to include alcohol calories, but that is an important thing to realize. So let's practice this. Using the example below, you have a person who has been determined to need 2,094 calories per day. And with your expertise, you've determined that these is the breakdown of their macronutrient needs. So now let's convert those into grams so that we can apply it to their diet. So first, step 1. Let's see if you're going through step 1. Let's do this separately. You're going to have the total calories, 2,094. Now you're going to multiply that times 36%, but you need, when you do math, to put percentages into decimal form. So 36% is 0.36 in decimal form. After that, we just do the simple math, and the calculator is going to tell me that the answer is 753.84 calories, and that is from fat. Now, we don't care about those 8.84 calories, but it's already on your calculator screen, so just leave it there because we have another step to do on that. The step 2 is to take the calories from the macronutrient and then divide by the calories per gram. Now we're talking about fat, so we're going to know that, oh, I have to use 9 for fat. So we take that and we divide by 9 calories per gram. And remember, in math, we can cross out those units, and sometimes that helps to remember what you're solving for. So when we divide by 9 calories per gram, we are going to come up with 83.76 grams. Now, again, in nutrition, 0.76 grams is not important. So we're always going to round to the nearest gram. So let's round up since it's 0.76, and that would be 84 grams of fat. So let's now do the next one in line, which is saturated fat. So we do the same thing essentially. We take 2,094, and we multiply it times 7%. And remember, 7% expressed as a decimal is 0.07. So if we do that math, we are going to come up with 146.58 calories. We're going to leave that on our calculator. We're going to divide by 9 calories per gram, because saturated fat calories have the same amount of calories as any other kind of fat. They just have a different health properties. So we like to exclude those out and look at those grams independently. So the calculator told me that I had 16.28 grams of saturated fat. And of course, I'm going to round down. So I'm going to call it 16 grams. So the person should limit their saturated fat intake to ideally to less than 16 grams. Moving along to carbohydrate, which is the same, but you have to be careful about your conversion. So we need 45% carbohydrate. So we're going to convert 45% into 0.45. We are going to get 942.3 calories from carbohydrate. We are going to divide by now 4 calories per gram. We're going to cancel those out, and we're going to find that there are 235.575 grams of carbohydrate. So we're going to round up to 36. So this person would want to eat around 236 grams of carbohydrates per day. Lastly, let's do protein. So you should be rolling along easily with this. So 2,094 times 0.19 is 397.86 calories from protein. We're going to divide by 4 calories per gram. And our trusty calculators are going to tell us that that is 99.46 grams of protein, and we're going to round it on down to 99. So this person would want to eat around 99 grams of protein. So I hope that helped. If you have any questions, please contact me and I can try to point you to more resources to get a little more proficient at doing this.